alignment and all, and why we are going for this multiple sequence alignment. Okay, today we will be discussing about some three tools like cluster W, multi-align, and die-align. Using these three tools, we are gonna see like how this multiple like the sequences are aligning in different formats. So first, we will see about the cluster W. This cluster W is like widely used tool. Like everybody is using this tool like because of its high accuracy and those things. And like why we while aligning, like it can align n number of sequences. It's homologous nucleotide sequence or protein sequences can align both the sequences. And it was first given by the in 1994. It was introduced in 1994 by Thomson, Higgins, and Gibson. Like those are the programmers who worked on that one. And this W with this like cluster W, like we are saying cluster and W is like the W denotes the version of the cluster program.
Excuse me, ma'am.
Yes.
Ma'am, are you sharing the screen?
No. I'm not
Oh,
stating it. Okay.
okay, okay, ma'am.
Okay. I will share like whenever I start that experiment. Okay. Uh, then like the W is there, right? That denotes the version of the cluster program. We are having cluster omega, cluster W. Those two things we are widely using. So that denotes the version. And what will happen in this cluster W. So this is also against it will also works like a pairwise alignment. First, it will pairwise align all the sequences. If I am having five sequences, one and two, two and three, three and four, four and five, like that, it will make an alignment for those two things, and it will put everything in a matrix. So sequence versus sequence, like that, it will create. Then what will happen again? That then it will create a distance matrix. First, it will put like aligning matrices in one thing, and it will create a distance matrix between two, generate the evolutionary distance between those two sequences. If one and three are having a close proximity, it will put that one and two in from like that one and two closely than five. Like that, it will create. Then generally while creating the thing, it will create a guide tree. Also, it will create like to show like how it is like working on that thing, and it's mainly like working based on neighbor joining algorithm. You have studied that neighbor joining parsimony methods, right, in multiple sequence alignment. In sequence analysis paper, I don't think you have studied. Is it there in syllabus? Yeah, it is there, I guess, in syllabus. Uh, Amuta ma'am used to take that class, I guess. Hmm, who taught you that thing?
Side, sir.
Okay, he taught you, na, then no problem. Like neighbor joining clustering algorithm. Then, and progressively, it will align the sequences from one point. Like guide tree it is creating, right? From that point, it used to create a distance matrices for each and every sequences, and try to create a like evolutionary map for our sequences. So how? Okay, let's do the experiment. While doing, you will get to know how it's working like that. I will share the screen. We are using this cluster W, right? Multiple sequence element using cluster W. Here, if you see the output format, this is the one we are using. Output format we want in cluster format, and pairwise element we are using like fast approximate thing. And enter your sequences with labels, protein or DNA, which sequence you want you can use. And support formats FASTA, NBRF, whatever format we are having we can give, or else we can give one by one sequences, or we can choose the file and execute multiple alignment. So for right now, I'll be okay. You know how to download multiple sequences at one go in NCBA? Does anybody know?
You're talking about batch download?
Yes, batch download. Can you guys do that thing? Or simple way I'll show you not very big deal. For example, if I want to download a protein, okay, this is transcription factor proteins from different organisms. It is there. If you see Homo sapiens is there, Muscular is there, different species are there. So if because I'm creating multiple sequence, right? So that's why I want to ask you one by one. I can give like I have to go to this faster page and then take the sequence and paste it there, or else I have to make into a like notepad file like one by one. Then I have to arrange it and then I have to add it. So what I can do is like at the side you can see the tick box. Is it visible? Yeah, that is
Yes.
visible. This transcription factor of Sayona intestinalis and the different one I'm choosing. You just choose according like wisely with different organisms. Laborohita and one is from Bankios. Then that this IDs are just too big. Like you just check it out like regarding like very small protein. And we'll take one from Gallus and from one from Homo sapiens and one from Mus musculus. So now I have selected some sequences. If you see here, I have selected around 6 sequences. So then what I have to do, send to. Can you see that send to at the right side corner? Like there,
Yes, ma'am.
you just have to click file and go to that format type. Instead of summary, you just download FASTA. Okay, which format you want. Like Genpep also you can use, but for uploading the sequence, that is not like we can't do that thing because Genpep will have locus ID and all those things. The description about those things will be there, so that is not needed for us. Only we need the FASTA sequence. So give FASTA and create a file. So then the file will be downloaded. Like whichever the thing you have downloaded, right? Like sequence you have selected, those things will be like downloaded. After downloading that thing, you just come to this page and choose a file. Like I'm choosing because I'm not like viewing those things. Like I'm just giving that query. Like if you see sequence 3.faster, this is a file name that I have downloaded. Then like we need to execute the multiple alignment. So in pairwise alignment parameters, for example, in pairwise alignment, the two things it will do, right? So if you want to increase your penalties and all, you can increase. Which method you want, like any like matrix you want to change, those things if you want to do, then you can do. Or else let it be, don't change the like pairwise alignment methods. Just try to execute it multiple alignment. So now it has been aligned. Can you able to see like how it is aligned? See, this cluster level multiple sequences, we have given the IDs of the sequences with AABB3. This thing, the details, it will be there in that file, like this page. Okay. Then, so if you see this thing, like I have downloaded transcription from different things, right? So this is one from Sayona intestinalis. This is from Labo Rohita. Like this, I have downloaded the sequence. Like from for 6 different sequences, I have downloaded, right? So now here, so now if you see here, this AAB belongs to Mus musculus, and this one is belongs to different organisms. So with the ID, we can check like which organism belongs to, like which sequence belongs to which organisms. This is how we have aligned the sequence, and there is we are not having any particular conserved residue for this thing. It's because only we are having some two, three single dots and double dots. I have already explained you in some tools what is the meaning of this double dot and single dot. So you should know by this time. Then what else we can do in this one? After receiving the retrieving the results, we need to check only by aligning the sequence we can't able to know which one is related to which one the closer, right? So we need that like that graph like phylogenetic tree to check which one is closer to which one. So for that, what you have to do, you have to go to the select tree menu. Select tree menu is there, right? Just give final, then execute. Then that page will load. Like it will move on to another page, and the job is still running. Let's see what kind of results we are getting. Wait for a few minutes. The page is still loading. Okay, we have received the results. Can you guys able to see the result page? Yes.
Yes, ma'am.
Yes. Okay. Okay. If you see here, they are showing you like what method they have followed. Non file like alignment and phylogenetic reconstruction performed with function build. Like what are the things they have algorithm they have used for this thing. Those details have been given in this one. And like final thing they are doing bootstrapping to get the like align the sequences, and rotatory and result files they have given you different formats like new NWK is new week format, we will say it is a new week format, uh, and FASTA entry format they have given, and phylogram they have given. So if you see without branch line, with branch labels, without labels, and without text. If you give without text, the numberings will go like that 1, 2, 3 is there, right? That will go to see the distance between those things. So if we don't want, we can just remove the things. If you leave labels, if you remove, then that will be difficult because with you have to know which one is which. So don't remove your leaf labels. Okay, and branch labels. Branch labels in the sense the distance between these two branch labels. If I remove the thing, the distance between the branches will go. So like better to keep it to see the distance between those two things. And without branch length in the sense, then the branch length will go like branch length. That is this like that if I remove that branch length, everything will become like an aligned one, properly aligned.